AI member, Tony Sharfman, who is excellent at doing astrophotography. He's done some wonderful pictures. He's been a longtime member of AAI. And the title of his presentation is The Future That Almost Was. So go ahead, Tony. Thank you.
Okay. So I don't have to tell you that. Let me show you. I don't have to tell you that the year 2001 didn't look like this. In fact, it's 2025 and it still does not look like this. But what if I told you that in the 70s and 80s we came very close to having, for example, human missions to Mars, maybe even elsewhere, and we could have had entire fleets of ships, at the very least in Earth orbit, probably heading somewhere. And then the most interesting thing about this is that this is not just a product of somebody's imagination. These are not projects that only existed on paper. There was a lot of research that was done. There were tests that were done. There was hardware that was built, and it actually worked. And yet, still, nothing happened. So this is the story of why nothing happened, and then how it almost happened. So before we get into why this didn't happen, a little bit about what these people were trying to do, what their hopes and dreams were, why they were so adamant about making this happen, and why they felt that the technology they had already wasn't good enough. So let's get back to the beginning of the space age. And this is the best stuff we have at the time. This is very impressive, of course. These are rockets the size of buildings. This one is capable of going to the moon, taking people to the moon. But fundamentally, the technology that these rockets use, chemical rockets, it's just burning stuff, right? You have some kind of fuel, you add an oxidizer, oxygen, let's say, you burn it, and then that's how your rocket works. That's not, the technology itself is not that impressive. So for example, fundamentally speaking, that rocket that I showed you before is not drastically different from this one. Obviously, it's much bigger. Obviously, it's much more capable. Obviously, it has computers now, but it's using the same process. It's just this is burning alcohol, that was burning liquid oxygen, liquid hydrogen, kerosene. So you're not gonna go very far with this technology, not to mention that this is an engine from that moon rocket, extremely complicated, lots of parts, very complicated plumbing, as you can see. It's always on the edge of trying to destroy itself. So it's like a controlled explosion, is how some people call it. And we can do better today. We have 3D printing, so you can replace a lot of these, like 100 of these parts could be one part. But obviously they didn't have this technology back then. So if we could simplify this, that would really help, but you're still using chemical propulsion, which is not very efficient. This giant moon rocket is only able to put 2 people, a buggy, and that lander on the moon, right? If you wanted to do missions to Mars, this is not even good enough. Now, let's say, let's say you were able to use these chemical rockets to put together a ship to Mars. You would do a bunch of launches because one launch is not enough. So you would put together blocks, right? You would launch like 5 of them, assemble them in orbit, put together a ship, and then this ship was going to go to Mars. Well, what other problems do you run into with this chemical propulsion on the way to Mars? So Mars is far away, right? It also has an elliptical orbit. which means sometimes it's a lot closer, sometimes it's further away. Really, the best way to go there is every 2 years. The best time to go there is every 2 years because, uh, as you can see, here it's a lot closer than it is over there. You have to wait until Earth catches up, and then you launch over here, or rise over there. And even then, using our best chemical rockets, that's going to take you like 6 months. Now, why is 6 months a big deal? Originally, when these missions were talked about, one of the problems people thought about was how are people going to do in an enclosed small space for 6 months? But we know now after the pandemic that people adjust to to being cooped up. And the space station, especially, there were missions there that had lasted over a year. Also very small space. So that's not really a problem. So what is a problem is something we call cosmic rays. This is radiation. Some of it comes from the sun. When the sun is very active, it will send a stream of these towards Earth. These are very energetic. So if they go through your ship, and they will because it's lightweight, it's thin, they will damage your DNA and you can get cancer. Lovely. Some of these come from supernova explosions. So they come from deep space. They have even more energy. They will easily go through your ship unless you have some kind of shielding, which makes it heavy. And if you make the ship heavy, then it's even more difficult to build it. It's going to take more launches to do it. So, if you want to go somewhere in the solar system, the goal is to get there as quickly as possible, to be exposed to as little hazards as possible. And that's what the people planning these missions were thinking. How can we make these trips faster? Now, is there a technology that has a lot more energy than burning stuff, these chemical rockets? Well, yes. We discovered in the 40s that this little chunk of plutonium here, the size of a grapefruit, has enough energy to destroy a city. That thing that I showed you is the actual core of a nuclear bomb. So if we could harness this power and use it for space travel, this would be way, way more powerful than anything that we've done before. Now, let me ask you a question that hopefully will make at least somebody laugh. Can we build a ship that would ride that nuclear explosion into space? Maybe several explosions, actually not get destroyed and get pushed into space by this explosion. Now, to us, this sounds absolutely insane, and it should. It sounded crazy to a lot of people back then, but this project attracted some actually well-known scientists that decided to do some calculations and see if this was possible. So, for example, one person that worked on this was called Freeman Dyson, and he was a math prodigy. He was world famous. Later, Oppenheimer invited him to Princeton University here in New Jersey. And people that knew this guy said he never crossed anything out because he never made mistakes. So people that found out he was working on this program wanted to join this program. He gave it credibility. It was like, if this guy thinks it's going to work, maybe it is going to work. Now, if you are fans of science fiction, you may have heard his last name before because he's also associated with something that some people call Dyson sphere. He actually called it the Dyson swarm. And then it turns out he didn't even come up with this idea. Some science fiction writer did, but he popularized it. That if you had a civilization that was so advanced, maybe a million years ahead of us. They need more energy than we get from the sun on Earth. They build this superstructure all around the star, massive, that collects energy and nothing goes to waste. Basically, you're trying to capture all the energy from the sun, star, everywhere. So maybe Dyson was kind of open to wacky ideas. Maybe he's not the best example of people working in this program. But on the other hand, you also have people like this guy. He is Stanislav Ulam. He came from the Manhattan Project. So he was actually one of the people that created the atomic bomb. And then, if you know a bit of history about nuclear weapons, he's kind of the father of the hydrogen bomb. Although Ed Teller would say he was, because he has a massive ego, had a massive ego. But they were working together, and this guy came up with the idea. So anyway, a lot of people that came up with the nuclear bomb went to work on this spaceship project. And they didn't say it directly, but I think to a lot of them, this was a way to redeem themselves. They didn't like the fact that they worked on weapons. And this looked like a way to use nuclear energy to do something positive, to do something good. So they assemble a team of about 50 people eventually. Very, I would say, well-known, very creative scientists. And they start working on this. But the other thing you have to remember is this was a different time. People were not terrified of nuclear weapons yet. They didn't have that fear and terror that we have now, because this stuff was new and nobody really knew what it was capable of. And in fact, what's really insane is, here's a picture of Las Vegas. You can see a nuclear explosion in the background. This era in Vegas was called atomic tourism, where these tests were carried out so regularly that this was a tourist attraction. You would book yourself a room in a hotel and you could watch it from your window. It would attract a lot of people just taking pictures, the press here. Also, to show you how regular this was, here's a picture from 1965. You can see a few craters. This is in Nevada, about 60 miles from Las Vegas. This is a picture from 2018. And this is not even the whole field. This is about half of it. If you go on Google Earth, you can find this, and it's mind-boggling. They exploded these in neat little rows. There are roads leading up to this stuff. There's probably dozens and dozens of these craters. So it's very well organized, but also you can tell how many of these tests were going on. Of course, to the people in Vegas, this seemed like entertainment. Here's a crazy picture somebody came up with where he got a ballerina to pose in front of an explosion. Then this one is called Miss Atomic Bomb. This was a Las Vegas showgirl. So again, this is done.
Okay, we're back. Let's see now. Um, on the desktop.
Unless it's
Uh,
I mean, it's located on the desktop. I copied it over to the desktop.
okay, so let's see. Then I should be able to see. I'm not seeing it.
I mean, I need to open it.
Oh, okay. So you can probably minimize this
Minimize this.
and then go to
I just copied it to this desktop.
open up the file explorer.
This is not to do it again.
Please stand by. All right, so that should be good. We should get the okay.
Yep, that's the PowerPoint.
That's already advanced.
Now, slideshow from the beginning, and then I have to go back to the desktop to the screen name, this up, and then
And then recording, right?
oh, record.
Well, never mind.
Never
It's
mind.
been ruined.
Yeah,
Here's your phone.
yeah, we will.
Thank you.
Thank you.
Okay. Let me just skip around a little bit. Okay, so I showed you this. Now, I'm sure all of these people regretted it later. Yeah, this one is called misradiation, believe it or not. Now, while these people were having fun with this stuff, the actual scientists were trying to do these tests for research. So they're studying how the shock wave, which you can see here, travels. You can see it, you can see it bounce off the ground. They're studying temperatures, they're studying pressures. And one incredibly one thing that they realize is that things can survive these explosions. They purposely set up a test where they place steel poles close to the blast, a bit further away, and then they find that they survived. They were not vaporized. The explosion just pushed them out of the way. So they were, mashed, crumpled, but not vaporized. And that was the first test that told these people, hey, this crazy spaceship idea might actually work. So what did they come up with? They come up with this. It's called Project Orion. And here's a better illustration for you. And the way this thing would work is you have this massive steel plate here. Then the explosion would happen, boom, it bounces, of course, the steel plate, it pushes it. Now, the thing is, if that was the only thing you had on this ship, the acceleration would smash you through the ceiling. So you need some kind of shock absorbing system that would take that acceleration and make it bearable for humans. So they have these things which would work like springs, basically. Plus, there's another one in this plate as well. I'll show you a video shortly how this would work. And then you build this gigantic ship. And what's really interesting about this is it doesn't have to be lightweight, obviously, because you're trying to withstand a nuclear explosion. The thing about all the spacecraft we build now is they're using lightweight exotic materials, right? Aluminum, titanium. We try to make them as light as possible. For something like this, that doesn't matter at all. In fact, if the ship is heavy, you just make the explosion bigger. So what's crazy about this idea is one explosion would not be enough to get you to orbit. You would need to have multiple explosions happening to keep pushing your ship. So you would have hundreds of little bombs sitting in these magazines. They call it a magazine just like a gun would. They would dump it through this opening here behind the ship and explode it about once every second. So you need hundreds of these explosions to get to space. And on the other hand, because like I said, it doesn't have to use any fancy materials, we thought of this thing as, imagine building the Brooklyn Bridge, imagine building a skyscraper. You can make it out of steel. You can use, or a submarine, like think of it that way. Very thick construction. I think the first version of this was thousands of tons, and it was going to be like 200 yards across on the base here. So this thing is massive. Now, moving along. Hopefully this plays. This is an animation of, this is slowed down first, and then you'll see it real time of how the shock absorber was supposed to work. You would get to the end of the travel, and then it would get back, and it would keep cycling like this. And then this is actually real time. So here's where this gets interesting, because if that's all that happened with this program, they came up with these sketches, they did the calculations, I would have said, okay, interesting, but another crazy idea that somebody had on paper, that never happened. But they built scale models to see if this explosion theory actually worked. And that's what actually made this program possible, because they showed this stuff to, for example, people in the Air Force who were just as skeptical as all of you here. And they were like, this is insane. And then they see this and they're like, take our money. This is going to work. So here are a few tests I'll play for you. This is all slow motion, so you can see how the explosion works. Well, okay, first test is just to figure out, is the explosion going to destroy the ship? No, it does not vaporize it, ship keeps flying. And then as we're moving along, they get more sophisticated with these tests. It's, can we pump up an explosion periodically to keep this thing flying? Is it gonna fall over? Is it gonna go straight? Is it possible for it to keep flying straight? Yes, it actually works. When I first saw this stuff, I almost fell out of my chair. I was like, no way. So there were a bunch of these tests that they did from, I think, 58 to 61. And everybody that saw it basically said, amazing. So here's one with sound, and I think it's real time. So this will actually give you an idea what it was like. Oh, we don't have sound. But you can see it works.
That's not nuclear, is it? That's just.
These are just regular explosives, because this thing is, this model is like, it's not that big, but it's a proof of concept. And that was enough to get millions of dollars in funding to keep this thing going. So to give you more detail about how this thing would have worked, here's a sketch. Yeah, so that's actually another thing I should mention. This thing was completely classified because this is using nuclear bombs. And to make this thing work, you need hundreds of very small nuclear bombs. So if you learn how to make very small nuclear bombs, that's, according to them, an ideal thing for terrorists. If they figured out, hey, you can do a small bomb and you can make it cheap, everybody would try to build one. So the bomb part of this is still classified to this day, even though this is from the 50s. But you can see here, I was talking about steel plate, and we have our shock absorbers here, magazines with bombs. Now, to make the magazines work, they actually contacted the Coca-Cola company, who were experts at assembly lines and vending machines. And they were like, these guys are geniuses at making things go, like hundreds of little cans go through a conveyor and then get thrown out of a hole or whatever. So we need to talk to them and figure out how they do it so we can do it. You can see another sketch here. This is magazines of bombs that you would, here's an example of one of these. So you can see it has a nuclear charge here, and then it has some material, filler, which is beryllium and tungsten. So this gets vaporized when the bomb explodes, so that it gives it there's some mass that it can work on, and that will push the plate. It's basically called a nuclear shaped charge because instead of going in every direction, it's designed to make like a blast in a single direction. And then if these ships were actually flying, then, 1 second, you would be ejecting these magazines as they got empty, basically. So this started out as basically a top secret project that General Atomics was working on, which was this weird agency that was trying to come up with useful uses of nuclear research. And then they were like, okay, who can we get to use this and actually build this? So one of the ideas was to talk to NASA. So NASA did do some concepts. Here's one that was going to Mars. The thing about these Orion ships, obviously, that should occur to you is you can't land it. You need some kind of shuttle system to get from here to the surface and back to the ship. And the same thing will be happening on Earth. The NASA version 2 would have been smaller because NASA was concerned about launching this thing from the ground and all the radiation it would create. So this would have been riding on the Saturn V rocket as a second stage. So it goes up, let's say, 90 miles on a regular rocket, and then the next stage is all nuclear. Boom, 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 boom. The problem, actually, surprisingly, is this thing is hard to scale down because everything is heavy steel. The shock absorbers can't really be scaled down a lot because they still need to do their job. The plate works worse if it's small, stuff like that. So the other thing with NASA was this program was classified, and NASA hated working on anything that was classified because it's a public agency. So they're like, either declassified or we're not interested. And the other thing is they were working on their lunar program. This is a distraction. They're sinking all this effort into the normal Saturn V, and these people are coming to them with this nuclear stuff, and they're like, we're just focused on this one thing, okay? So that didn't go anywhere. But let's say that NASA did create a stack like this. So you launch it up in the atmosphere, and we know that nuclear explosions on the ground are problematic because of fallout. What happens to a nuclear explosion in space? Is that safer? Is that any better? Well, obviously, this was going to take additional research. I'll give you a little hint. That's not a moon. The military was all too handy, of course, to do this because they love blowing stuff up and seeing what happens. So this was a military program called Project Fishbowl, where basically that's all it is. Let's take a nuclear weapon, launch it into space, and see what happens. I should say that playing with nuclear weapons is dangerous because the first 3 launches of this thing failed. The rocket carrying the bomb exploded right on the pad and contaminated the entire facility. And pieces of the rocket fell into the ocean, and they had to fish this thing out. And everything was very radioactive. So this is years before Chernobyl. These poor people had to deal with this nuclear contamination. I don't even think they knew what they were dealing with, honestly. So as you can imagine, I've read stories of people from the Navy saying the amount of illness in crews that were stationed on these islands was huge. But if they keep trying, this did not stop them, as you can imagine. Eventually, they did launch nuclear weapons into space, and it looked nothing like anybody was expecting. It actually doesn't look that amazing because there's no air or anything. So you really, a lot of what you get is radiation. You get a ball that creates radioactive particles going anywhere. And here's another picture for you. So they spent a lot of money doing these tests, and it seems like they spent very little money on good cameras. I don't know why, but we do have some footage that I actually upscaled in AI. So I did use AI to fix this, but this is not AI footage, it's real. And then you can see how these tests looked. And they were, I think, 5 or 6 of them total.
How far up was that?
So they were different heights. That's another thing they were testing. I built one that was 250 miles. There was one that was only 45 miles. And there was one that was like 1,000 miles. Okay, so if you were on the ground watching this, one of the things that you saw was this pretty aurora display. But if you know anything about auroras, you should be concerned if you see something like this. Because what is an aurora? Well, in our case, these are caused by the sun. This happens when, again, charged particles that I talked about slam into the atmosphere and they make the air glow. Now, because our Earth has a magnetic field, we can't see, but of course it's there. And it goes basically from pole to pole like this. Once these particles get near Earth, the magnetic field makes them go in these loops around. And that's why the concentration you see is mostly here and here, because that's where most of them will wind up. And from what I understand, these particles kind of travel back and forth like this along these field lines. So here's an example at the South Pole. You can see it creates a ring here. But if you're at the space station, you get a really amazing experience looking at this. So that's pretty, but why is it a problem? Well, what's happening is that it is radiation, and you're, first of all, creating a radiation field around the Earth when you do this. So you're familiar with the Van Allen belts, which are belts of charged particles traveling around the Earth. These bombs created an artificial one. It was more powerful, and it destroyed 1/3 of all the satellites that were up there at that moment. Now, lucky for them, because this was 1962, that number was like 7 satellites. But so you can imagine if you did this today, it'd be thousands of satellites. What happens to a satellite is when you wind up in that radiation belt, it fries your electronics on the satellite. And this belt that they created lasted for 5 years before it disappeared, because that was a thermonuclear bomb that they exploded. It was 1 megaton, the most powerful one, Starfish Prime. And nobody expected this. But the other thing that happened that they also did not expect is they created something called an electromagnetic pulse, EMP. And they discovered that if you blow up a bomb in space, all this radiation, gamma rays, are going to slam into the atmosphere, knock out electrons from the air, and these electrons are going to travel down. Well, they travel along our field lines, but some are going to travel down, and that's going to fry everything on the ground. So these tests were conducted in the Pacific Ocean on small islands. I think it was 1,000 miles away from Hawaii. And that was enough to fry streetlights in Hawaii, transformers. And then they discovered that if you were to take one of these bombs, blow it up, let's say, on top of the, I don't know, Nebraska, let's say, middle of the country, you could theoretically knock down all the electrical grids in the entire US system. If you had an explosion big enough, that's what it would do. So that's another nail on the coffin of this project, because it's not safe on the ground, it's not safe in space. It's safe if you travel away from Earth and then blow these bombs up there, maybe. But you can see how many issues this would have caused if they actually created this stuff. So I just told you NASA was not interested. I told you people are getting concerned. The last hope of the people working on this project was the military. They went to the Air Force, and the Air Force got super excited because when they looked at this, they saw a space battleship where you could have this Orion loaded with nuclear weapons that could launch them, hundreds of them, dozens of them. It had guns on it, because why not? Self-defense in case somebody tries to blow up your battleship in space. And it was huge. So you could build a fleet of these things, and then, as one general put it, if you control Orion, you control the world. So believe it or not, they saw the tests that I showed you where they used normal explosives and then saw that the thing actually went up, up, up. That was enough to convince them that, hey, this would probably work, and give them a budget. They were working on this. And it went very high up the chain, I think, to the level of generals in the Air Force that were all like, this is great. Until somebody had this idea of showing it to the president. And so they built a scale model of this battleship that I hear actually exists, but nobody knows where it is. It's apparently the size of a car, and they were super proud of it. And they invited the president and they showed it to him. And he did not react the way they thought. He was horrified. He thought it was a terrible idea. and he told them he would never support it. So, because the president didn't support it, here's another example with the battleship fleet. And because of the EMP issues that I just showed you, in fact, in 1963, the Americans and the Russians and a few countries signed a treaty to stop doing these stupid tests. It was called the Partial Test Ban Treaty, and starting from that point, no more explosions on the ground, in space, or in the ocean. The only explosions that would be allowed would be underground. And that was basically the end of that project. Now, personally, I think if the Air Force convinced the president that this was a good idea, they would have ignored the treaty. But because they couldn't, the project was dead. So, but nuclear energy doesn't necessarily have to be only used as an explosion, right? We can use it to heat stuff. This is basically how every single nuclear power plant in the world works. All we're doing is using the energy of nuclear material to produce heat. It heats water. Water runs a turbine. Turbine produces electricity. So the point is that explosions are not the only way, nuclear explosions are not the only way to create energy. And we, of course, use them on nuclear submarines. So later in the 60s, there was a different idea of using nuclear technology to produce engines. And this was called NERVA program. And this is nuclear thermal propulsion. This is actually a very simple, neat concept where you have nuclear material sitting inside here, inside a reactor core. It's producing heat. You take a bunch of hydrogen, you pump it through a pipe through this nuclear material, it gets hot, and you exhaust it out, and boom, you have a rocket engine. It's very simple, not a lot of moving parts. Nuclear technology is understood by that point. So they decide to see, hey, can this work? Can we build this? Here's a better illustration for you. You can see it's not a very complicated system compared to the chemical rocket engines I showed you before with like a billion little valves and pipes going everywhere. And they've built a bunch of these. They started with smaller ones, they developed bigger ones. They actually made very powerful ones. They test fired them for minutes at a time. And they worked. Now, the very first ones, of course, they ran into some technical issues where, you know, the hydrogen was reacting with fissile material, it was eroding it, but they fixed that later using different materials. And then here, they basically drove this thing out in the desert and lit it up, and it worked. Now, that meant that our Mars ship using nuclear thermal engines would have looked more like this. No explosions, no big metal plate, but basically, you know, using nuclear propulsion to get to Mars, not in 6 months, but let's say 45 days. Because the advantage of these nuclear engines, as you can imagine, is they produce a lot more power, more thrust, they're a lot more efficient, so they can fly faster. And that's one of the problems these guys were trying to solve. They would have flown faster. So one thing I should mention for the science fiction fans, by the way, is the spaceship Discovery in 2001 is one of these nuclear thermal spacecraft. This is nuclear thermal engine in the back, and this is why you have this long section to keep the people here far away from the radioactive stuff in the back. The actual thing would have looked more like this. They actually did some design studies, You can see that it has the landing craft in the front. It has the stacks of these engines in the back. Here's another example of the front of this thing. And they got a lot of studies done. They were very excited about this. They actually thought this was going to happen. You still would have had to launch this stuff on a Saturn V because you're not going to launch it from the ground. And you probably would have built an even bigger one. But back then, everybody was very optimistic about this. So nobody thought it couldn't be done. But of course, I don't have to tell you that the lunar program got canceled. There were complete Saturn V's that were sent to museums, like this one here. So the administration didn't even want to keep flying to the moon. There was no question at that point of flying to Mars. Nobody wanted to spend the money. And that's how that program died. And that's, you know, we got very close to this stuff actually happening. But I'm going to go off on a bit of a tangent now, but I think you'll find it interesting and hopefully entertaining. So, in addition to working on nuclear propulsion for rockets, you can imagine that everybody was trying to cram these nuclear reactors in everything. Submarines, and one of them was planes. So this was an idea for a nuclear-powered airplane, where, in theory, you could keep flying for months. You're only limited by the amount of food you have. You would have to rotate the pilots and stuff, but you'd never have to refuel. So the military, again, thought this was a great idea. They started working on this. They actually created nuclear jet engines, where what that's doing is getting air in, heating it up, and exhausting it out. These were never tested on a plane, they were tested on the ground. So actually, these planes, all they did was put a nuclear reactor inside the plane, ran it, and see if, for example, the amount of radiation was bearable for pilots here. They had to build an 11-ton shield for these people to keep them safe. I hear it was like very thick balls of lead and stuff like that. But, you know, the question then is, what happens if your nuclear plane crashes? Now you have another mini Chernobyl situation, just like with the rockets that I showed you. Somebody's going to have to clean this mess up. So one neat technology that they came up with was this Beetle robot. This is like a 1950s mechanized suit where there's a guy inside it. This thing is about 70 tons. It's using a chassis from a tank. It can go up and down. I'll show you that in a bit. This is a project between General Electric and General Mills. And yes, it's the General Mills. Because if you, I don't know if any of you remember my talk on spy satellites, I mentioned that back then, space was so popular that all these regular companies were trying to get in on it. So for example, the Ball Jar company created Ball Aerospace, you know, the logo there. And this actually existed all the way until last year, until it was bought by a British weapons manufacturer. So General Mills and General Electric come up with this thing that would do the nuclear cleanup. So you have a guy inside this thing. There's a very thick layer of glass to protect you from the radiation. Now, they did a lot of neat photo shoots with this. You can see it's holding an egg and it's not crushing it. So they're trying to tell you, yeah, this is powerful enough to rip apart metal plates, but it's also delicate enough to be able to do stuff like this. And well, of course, they had to get models to pose with this stuff because this is the 1950s. They're also showing that it's not ripping her hands out. This is the view from inside. And apparently, This thing had a lot of bugs, it kept breaking down, but they did train people to be able to use it. So you can see the scale. These two guys are on top of this thing here. Now, that program got canceled when the nuclear bomber got canceled. The nuclear bomber did 40 flights, I think, and then people were like, why do we need this? We have nuclear missiles. Nobody needs these planes. Stop it. But the neat thing is General Mills took that technology and created this Elven submersible. And some of you might know this was the first thing to go down to the Titanic. It was designed to go down to 4 miles, I believe. And then a lot of this technology of using robotic hands and stuff, that came from that earlier project. And a lot of neat technology was being developed because of this nuclear cleanup idea. So this is called the handyman. You can see this guy is using this contraption here to control this contraption here. And supposedly he could do a hula hoop with this robot hands in the 1950s with some very terrified looking kids. Now, this one is called the Hardy Man. This is an idea to develop an exoskeleton. You're only seeing one hand here, but it actually looked more like this. So this is one of those very rare cases that I can think of where science fiction came after the actual classified research that they were doing. They already had these, let's say, mech suits back then. They just got canceled. This was a walking attraction. This is neat. They call this a walking truck. There's actually video of them testing this thing. So the picture looks more elegant than how it actually worked. But they'll show you that you can get over obstacles. You can be sure that if space exploration took off, we would have these things on different planets as well. That's what I would imagine. Of course, this was developed by the military to carry soldiers, and I think they show an example of him like helping a truck out of being stuck in the mud. Not crushing a light bulb. So it existed, it worked. So I think this is my last slide. What I'm trying to say here is this is from the 80s. That stuff was from the 50s. This came way later. And I had no idea that even existed. Pretty interesting. And thank you guys very much.
There you Anybody have any questions? I should have been scared, huh?
Yep.
Yeah. Anybody online? Or Bonnie?
Let me check.
Go ahead.
Yeah, Tony?
Yep.
You said that one ship that was built was going to have guns. Just
Right,
because
right.
you put guns. But if you really shot it, you have an action-reaction. So if you shot it, it would go out of orbit, or at least change its position. Right?
Oh yeah, it would shift it for sure. So I'm not sure what they were thinking with that. It was
Yeah,
probably,
Shoot out both sides?
but they saw it as a technological problem.
And they were so optimistic about this stuff. All the tests that they were doing were working. So I guess they figured they could probably figure that out too.
But it seems that we were more in danger from our own government than we were from Cuba.
Yeah, well, you saw the amount of craters that they had.
Yeah.
And that's the other thing I should mention. Like when this program started, they were very optimistic about nuclear power, nuclear energy. It was going to fix all our problems. And then, literally 5 years later, when they realized there's radiation in milk, they were like, shut it down. So there was a very brief period of that optimism. And then after that, it was like, nuclear weapons are terrible. We should probably stop this.
Did they have any idea of how it had worked out in Japan? So,
Yeah, you would think, right? And that was like a good 10 years earlier.
right.
But I don't know why they thought this was a good idea.
That was really